Kia ora tātou. Welcome to this final video on rates of reaction for the chemical reactivity standard. So in this video we're looking at catalysts. So you might have been introduced to the idea of catalysts in year 11, but you never get tested on that in the exam. In this case, there's a good chance that you will be tested on catalysts, so it's a good thing to know about. So what is a catalyst? A catalyst is a substance that will increase the rate of reaction by providing an alternative pathway for the reaction to occur. So let's draw out what that could look like if we've got some reactants that combine together and then they go into this. So let's show the graph like we did with the temperature, where we've got the activation energy, EA, and then we've got the change in enthalpy of the reaction there. So this is the energy, reaction progress. So if this reaction was to occur without any catalysts, then this is the amount of energy that would be required for those reactions to occur. So that would mean that we would need to provide a certain amount of energy for these reactants for them to be able to collide effectively. If we add a catalyst in, so that could be anything. Sometimes it's as simple as like zinc metal, sometimes it's more complicated than that, but you won't need to remember any examples of catalysts. It's always given to you in the question. So the catalyst would provide an alternative pathway for the reaction. So we often show this as a dotted line. So this means that instead of the reactants needing this much energy here to react, they now only need this much energy here to react. So the effect of that is that more of these particles are going to have sufficient energy to overcome the activation energy barrier, and so we're going to get more collisions that result in a reaction. Let's have a look at a past exam question. So consider the following observations in another experiment using hydrogen peroxide. This is question B from 2018, so question A must have had hydrogen peroxide as well. When hydrogen peroxide is mixed with solution X, which contains universal indicator, the color changes from blue to green to yellow to orange over a time of 1 hour. If a crystal of ammonium molybdate is added to solution X before the hydrogen peroxide is added, the same color changes will be seen in 3 to 4 minutes. Identify and explain the role of ammonium molybdate. Use a diagram and refer to activation energy in your answer. So first of all, we just need to identify the role of ammonium molybdate, and that is it is a catalyst. And so we'd say that this lowers the activation energy of the reaction by providing an alternative pathway for the reaction. Pathway. So what this means is that more reactant particles will have sufficient energy for a reaction to occur. Therefore, the rate of reaction will increase. And we can show that using a diagram in the exam. That should give you space to do this. And we would just do what I did before, where we've got the reactants there, the products there, and then we show using a dotted line what will happen with the catalyst. So we'd show here, this is the activation energy without a catalyst, and this here is the activation energy with a catalyst. It's basically just a scribble down there. Alright, so let's have a look at what the model answer would be. So the ammonium molybdate is a catalyst which speeds up the rate of reaction by providing an alternative pathway. I like the sound of that. Like, it's just great to be able to introduce that into your answer, an alternative pathway. What does that actually mean? Sometimes that can mean that the catalyst is providing a surface for the reaction to occur, so it's kind of like bringing them closer together, and they require less energy for the reaction to happen. But yeah, each catalyst will have its own way of providing that alternative pathway. For the reaction to occur with a lower activation energy barrier to be overcome, now more reactants will have sufficient energy to overcome the activation energy, resulting in an increase in the rate of reaction. So we're not accepting that collide with greater force. So we're talking about activation energy. So there's more energy for reaction to happen, not force. You might have used that a couple of times in year 11, and the answer schedule would let you get away with that. So here's our diagram here, which is what we did. I think this is the first time in these videos that I've actually got the answer close enough to the model answer. So it is, they can be a little bit nitpicky about these, so practice writing your answer, and then in the exam just like go NATO with your answers, just add in everything you can and hope that'll be sufficient for an excellence. Cool. So that is rates of reaction done. Very happy to get through this, because it is really just like a small step up from last year, but what you need to write in the exam answers is a little bit further. So the next part that we're going to get into, equilibrium reactions, is all completely new this year, but very relevant for chemistry and really important to know going forward if you're doing year 13 and chemistry at university. So thanks for watching these rates of reactions videos. We'll see you for chemical equilibrium.